In this video, we're going to solve a quadratic equation. There are four ways we can solve quadratics. The first way you can solve is by factoring, and that's what we're going to do here, but there are three more ways. Let me list those out for you. You can use the square root method. You can also use completing the square. And finally, you can use the quadratic formula. Which method you choose depends on the problem that you're given. Typically, with a factoring problem, it's advantageous to use factoring if it can be factored. When problems cannot be factored, you typically start to use methods 3 and 4 or possibly method 2. There will be videos following this one that will show you how to do each of these four methods. So again, for now, we're going to do factoring. Now, a little background on quadratic equations. In a typical simple math problem, say 2x plus 5 equals 11, this would be a linear equation that maybe you're more familiar with. What we try to do here is we isolate the variable from the number. So we put constants on one side and variables on the other, and then we divide both sides by 2 in this case, and get our solution as x equals to 3. The difference with quadratics you must always, no matter which method you use, in fact, except for a small exclusion of the square root method, you want to get everything on one side and 0 on the other. And in fact, this is what we'll call the standard form of the quadratic equation, where we have some coefficient times x squared, some coefficient times x, and then some coefficient without any variable on it, and we put that equals to 0. And that's the strategy we're going to use to solve these. So in this problem, I have x squared and I have 8x minus 15. Now, for reasons that I'll explain, it's advantageous if x squared is positive to leave it that way and move the other terms to that side. So I'm going to subtract 8x from this side, and I'm going to add 15. And likewise, I do the same on the other side. So again, algebra, no matter whether it's linear or quadratic, algebra must stay balanced. So that converts this problem to x squared minus 8x plus 15 equals to 0. Now, some of you know exactly what to do from this point, and if that's the case, then by all means go ahead and do that. And some people realize this construct here, where we're trying to find the numbers that multiply to give 15 and add to give negative 8. If that's you, you can go ahead and jump ahead in the video if you know how to do that. I'm going to step back and explain that for people that don't realize this. I'm going to give you a little hypothetical problem here. Let's look at x plus 4 times x minus 6. So if I try to multiply this out, I'm going to get x times x squared, x times negative 6, negative 6x, 4 times x is positive 4x, and then 4 times negative 6 is negative 24. And then we learn that we can combine these two terms in the middle because they're like terms. And so we have x squared minus 2x minus 24. Now, this is where I want to step back and look at where these two numbers, negative 2 and negative 24, come from. All right, so how did we get negative 24? We got that from taking this final step here, 4 times negative 6. So negative 24 came from taking 4 times negative 6. So where did negative 2 come from? Negative 2 came from the inner and the outer step right here, right? We took and we got negative 6x and plus 4. And so this was a result of taking 4 plus negative 6. So notice this coefficient right here always comes from adding two numbers, and this coefficient at the end comes from multiplying those same two numbers. So we have a pair of numbers that multiply to give negative 24, and they add to give negative 2. And so when we want to solve one of these equations and go in reverse from a quadratic back to a pair of factored binomials, we need to find numbers that multiply to give 15, and they must add to give negative 8. All right, so there's obviously an infinite number of ways you can add numbers to get negative 8, but there's only a specific number of ways you can multiply integers at least and get 15. All right, so let's write out the ways you can multiply to get 15. You can take 1 times 15, and then the only other numbers that go into 15 are 3, and 3 goes into 15 5 times. So there are only two possibilities of ways to multiply integers to get 15. What we're looking for is ways to multiply to get 15 and add to get negative 8. So if I want to multiply and get a positive number, and I'm going to add and get negative numbers, how will that happen? So again, let me take another little sidebar discussion. All right, so I've created a little truth table here. If you add two positive numbers, what is the result? It's always positive. And if you multiply two positive numbers, you also always get positive. That's the easiest one most people understand. Now, if we're going to add two negative numbers, say negative 2 plus negative 7, both of those are negative, so the result of the addition will always be negative. If I multiply two negative numbers, I know that I always get positive when I multiply two negatives. Finally, if I add a positive to a negative, the result here, that's tricky. That's what we're going to say. The best I can tell you here is this depends. If the positive number is the big number, then the result of the addition would be positive. But if the negative were the larger absolute value of the two numbers, then it would be negative. But we do know that definitely when I multiply a positive times a negative, I always get negative. So this little table will help you understand what we're looking at here. So in my case, I'm multiplying and getting a positive number, and I'm adding and getting a negative number. So that means my two numbers must be negative. So it means that this is negative 1 times negative 15, or it's negative 3 times negative 5. And so what we do now is we take this one step further and say, well, what's negative 1 plus negative 15? And when I check that out, that's negative 16. That's not what I wanted. Let's try negative 3 plus negative 5, and hopefully you already see that negative 3 plus negative 5 is negative 8. And that is what we have here. So we have found a pair of numbers that multiplies to give positive 15 and adds to give negative 8. And those two numbers are negative 3 and negative 5. Now, we take from this step, we realize that if I have something here, x minus 3, times something here, this x minus 5, and they equal 0, if I can force either one of these things to become 0, the whole thing will become 0. For example, if x equals to 3, 3 minus 3 is 0, 3 minus 5 is negative 2, but that doesn't matter because 0 times negative 2 is still 0. Likewise, if I use x equals to 5, 5 minus 5 becomes 0. 5 minus 3 is 2, but it doesn't matter. That's 2 times 0, it's still 0. In this problem, you can probably see that x minus 3 equals 0 and x minus 5 equals 0 are the two possibilities that I'm looking at, and some people see already the answer has to be 3. But the reason it is because we set each of those two binomial factors equal to 0 and then solve. And so we get our final solution here, x equals 3 and x equals negative 5. Now, for some of you, this may seem strange because up here, we did this algebra problem that we started with, a linear one, and we only got one solution, and you may be accustomed to the idea of only getting one solution. But with a quadratic equation, we get two solutions, and in fact, we'll learn this in later lessons. The number of solutions you get is dependent upon the highest exponent in your problem. So we have x to the 2 power as our highest exponent, and that's the reason that we have two possible solutions. So the two solutions here are x equals 3 and x equals to 5. And if you would like to check this, you can go back and substitute 3 in for x and substitute 5 in for x, and you'll find that both of them create true statements. So if you don't feel good about your solution at the end, remember you can always go back and check and see if you got the correct answers.